Okay, so today's video is about histograms. This is a continuation of yesterday's video about frequency tables. So, what exactly is a histogram? Well, it's a visual representation of a frequency table. All right, so how to make a histogram. Step 1, make a frequency table. Of your data. Step 2, label your axes. Your x-axis, this is going to be your classes. Remember when we did this before? We had the classes that were like 0 to 20, 20 to 30, sorry, that'd be 20 to 40, 40 to 80. Okay, this is going to be on your x-axis. Your y-axis is going to be your frequency or the relative frequency. Step 3, fill in with data. All right. This example says use the data from the roadside service example in the 1.1b notes to create a histogram. So that would be yesterday's notes. But let me just draw you one so you can see what this looks like. A histogram looks a lot like a bar chart, right? The big difference between a histogram and a bar chart is that in a histogram, the bars touch. Okay. So they're going to say this is 20, this is 40, this is 60, this is 80, this is 100. Okay, and I'm going to make up values here. So let's say from 0 to 20, we had a frequency of 2. Let me change my color so you can see this better. So I'm going to draw my bar to here. Between 21 and 40, I had a frequency of 3. Between 41 and 60, I had a frequency of 5. Between 61 and 80, I had a frequency of 3. Between 80 and 100, I had a frequency of 7. Okay, so a histogram is just a visual representation of a frequency table. What this does for you, the advantage of the histogram over the frequency table is I can, at a glance at this histogram, see where the majority of my data is located. In this particular instance, right here, between 80 and 100 is where the majority of my data is located. All right. A class of students was asked to have the students record their weights. Here are the results. And we got all their weights. We want to create a histogram of the weights, use the class width of 40, starting at 100 pounds. All right. So if we're doing that, we're going to start at 100. So we're going to say 100 to 140. 141 to 180, 181 to 220, 221 to 240, 241 to 280, excuse me. And that should cover us because our biggest one here is this 265. Okay, and then we're going to count. So between 100 and 140, I have 1, 2, 3, 4, 5, 6, 7, 7. Between 141 and 180, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Between 181 and 220, I have 1, 2, 3. All right, and anybody notice what I did here? 241 to 280, this should be 22. This is what I did wrong. 41 to 80, 81 to 20, 21 to not be 40. Should be 21 to 60. There we go, and 261. to 300. Apologies there. Sometimes I can't add 40. All right, so between 221 and 260, I have okay, folks, I've messed up somewhere, but you get the idea, right? We're going to count which one falls into each category, and then we're going to draw our histogram. And our histogram should look something like this. Once we get it all done, okay. Because we're going to notice that most of our data is centered to the left, and I've got one guy over here on the right at this 265. All right, so next we need to talk about shape of our graph, symmetric versus skewed. So a symmetric graph means symmetry. So we all learned this in elementary school. It means when you fold it in half, it's the same on both sides. So a symmetric graph is going to look like this. All right, skewed left or skewed right. Okay, this one is a little counterintuitive. Okay, this one is skewed left. Even though the center of our data is over here, look at where the tail is. All right, the tail is this way, so we say this is skewed left. This one, again, the center of our data is here, but this is skewed right. All right, and this tells us about something of our data. So looking at our graph up here, our histogram, we see that the most of our data is over to the left and our tail is to the right. So this is skewed right. All right, unimodal versus bimodal versus trimodal. Okay, this is how many centers, how many clusters of data do we have? All right, unimodal, I've got one. Bimodal would look something like this, and you could probably figure out that trimodal is going to do this. Sometimes they're extreme, sometimes they're not so obvious, sometimes they're more subtle. All right, regardless, it's modal means the clusters of data. All right, an outlier, we've talked about this previously. An outlier is a piece of data that falls outside the trend. Going back up to our weights histogram, we have this one piece of information right here, this 265. Given that they told us these were students, I'm guessing this is a football player because he's much larger than the rest of them. So this is an outlier. When you are collecting your own data, you need to find out what the cause of the outlier is. Do you have an outlier because you made a mistake somewhere in your calculations? Or do you have an outlier because that is legitimate? If you made a mistake, you may need to go back and fix your data because outliers can drastically cause changes to the values of your data. For example, this outlier would drastically cause a shift in the average, the mean value of our data. So you need to make sure why outliers are there. All right, so describing data formally, we use an abbreviation, an acronym called SOX. What this stands for is shape. We're going to talk about this. This is normal. This is bimodal. Left skewed, right skewed. Remember on the skewed, we look at the tails. So we can describe the shape of our data, our graphical data, in many different ways. O talks about outliers. How about O-U-T? L-I-E-R-S. C is the center, where is the center of all of our data. And S talks about the spread. This is the range. So what values of data does this cover? In the case of our One up there we covered from like 123 pounds up to 265. That's our range. All right. Our example here says describe each of the histograms above using socks. We really just did that. All right, your homework. Pages 55 to 58, numbers 1.7 through 1.11 and 1.12a. As always, if you have any questions, email me, and good luck.